Thank you, Daniel. So, Ron from Nova Chemicals. I'm a simulator trainer there, and my background is in operations. So I've been in the hot seat enough times as well, and which kind of made me passionate about the simulator. I've qualified on 2 panels without a simulator and 2 with, and I was very grateful of the much easier to qualify with a simulator. So this is our Joffrey site up in Alberta. There's snow up there right now, but anyway, that gives you an idea of the, it's has 6 facilities on there. So I'll be talking about scenario-based training, a little bit about knowledge and decision-making, our simulator program, a training structure that we use, and our use of simulators other than just training. Oh, there we go. Okay. So our challenge, we require our panel operators to make million-plus decisions at time in very short durations. And procedures can fall short of addressing every possibility. We do use procedures quite a bit. They're very helpful, but our process is very complex, and we just can't write enough procedures to cover every possible eventuality. So we like simulator training. It's a practical training, and it helps our operators become better prepared for an actual response. We do use some classroom training as well, but just a written test doesn't really tell us if a panel operator is ready to handle a very complex upset. So look at the knowledge a little bit. This is would be termed as declarative knowledge. I came across the term inert knowledge, which it can become at times. And also, I've kind of drawn it as knowledge silos. So we typically learn information in from one manual or the procedures, but there isn't anything really to tie this information together, and which may make it inert. The operator might not know how to apply it. Our systems have a lot of integration. We could have a problem with one system. It might impact 2 or other 3 systems, and they may not have the skills to manage that. They may become overloaded very easily. So that's why we're interested in developing tacit knowledge. And so this is all the same systems, but we're working on getting them connected together. And I'm not very good at this button. There we go. Which we hope will develop experience. Another term for tacit knowledge, I guess you could say. And this, you can develop this in the actual plant, or you can do it training, and we like to train on the simulator to accomplish this development of the tacit knowledge. And it's all about pattern recognition. So it isn't necessarily a linear thought process. If any of you are from an operator facility and you've seen a panel operator struggling with a problem and somebody else walks up behind them, say an experienced panel operator, and points out, here's your problem after just glancing at the graphic, and this is how you fix it. So that would be an example of tacit knowledge. Very quickly can come to a resolution if they have that experience. But that's connecting all the systems together. And it can be hard to communicate. It's hard to document tacit knowledge in a manual. Just because it's so many layers to it, and it involves making connections and the mental model, which is the understanding of the operator's understanding of the process and how it's all interconnected. And you can gain this from years of experience on the panel, or we like to give our newer operators a chance ahead of time and train them on simulators. And this study really stood out for me. So this study said that in making decisions in critical situations, when there's time constraints, that approximately 90% of the time one course of action is determined and not a comparison of options. And I've seen studies that said it was more like 95% of the time, which I think is really good information. So, are we going to set our operators up to make that one course of action an accurate one, or are we going to just leave it to chance that they're going to make a good choice? And definitely we like them to compare options, but as we mentioned, this is with time constraints, which they are under the gun at times, and they don't have always time to compare options. They don't have time for an hour meeting to respond to an upset or try to figure a problem out. And traditionally, this is my number, 90% of the training focuses on this 10% of memorizing facts and following procedures. So one reason why we developed the simulator program was to let them practice decision making and be successful. This is a model of how our operators might make a decision. It's developed by Dr. Gary Klein. It's called the Recognition Prime Decision Model. And do I have a pointer on here? Okay. Well, I'm going to just, oh, is it on the left? No. Oh, this line. Ah, there we go. Okay. Thank you. So the recognition prime decision model, this is from studies in the actual field with people making critical decisions. And what they found is that, so we'll start with the situation. This is our malfunction, our problem in the unit. I added physiological responses. This is responding impacts due to stress, brain fog, freeze-ups even, where the panel op might be afraid to even respond. We'll talk more about that a little bit later. But so the situation leads to, generates cues, and that's what we're getting off the graphics or from the radio, phone, conversations. And that lets them recognize a pattern. And this is all based on their mental model and their biases, which why we like simulator training, so we can flush out those biases, so they have accurate mental models. And that's the comparison to normal as well, so they can look at the graphic, they have some idea of what a normal situation is, and they can pick up abnormalities. We might do that with alarming, light up the information to let them know, but also just picking up on other variables. So that pattern then activates an action script, or this is the response to the malfunction. Now, we don't want them just to go and act on the first thing that comes to mind, and this actually experienced critical decision makers do this naturally, but they assess it with a mental simulation. So they, in their mind, they will go, okay, if I take this action, what's going to be the result? And based on that simulation, they will then either adjust their response, or they might decide, no, I don't like that one at all, and I'm going back around and coming up with something newer, which should slow them down, but still accuracy is important in decision making. So they will then execute their action script and hopefully improve the situation. And this might take a couple loops around in our processes because an upset in one system might be impacting 2 or 3 others, and they might have to address those situations. Although they would know what caused it, but it still can it can have a boomerang effect. The second system could be upset and then come back around and get the first system. I'm afraid I'm going to hit it twice now. There we go. Okay, so simulators are an excellent tool for developing tacit knowledge and mental models. A little bit about our simulation programs. We have 3 ethylene facilities with both cracking and finishing. We have 2 panels in those units. One just has the finishing so far. 2 polyethylene plants with process and extrusion, both panels. One with just the process so far, and one we have an ethylene pipeline simulator as well. And 3 of these, we developed the simulator program before the plant started up. One's about to start up. So we've gained a lot of benefit from doing it that direction and when we update the units as well. A little bit about our training structure. In our ethylene 2 unit, we take them through 2 or 3 days of startup training. And this gets their hands on pretty much every controller. And also, it's more of a positive experience. They gain a little confidence from actually getting the plant to a steady state. Because the next stage is we're making quite a mess for them. We're tripping the plant, causing all kinds of chaos for them. And they're going to have to use their emergency procedures and trip applications that are associated with those procedures. And on that one, we give them a little bit we tell them what's going to happen, and we prep them, give them some coaching before they execute them. The next step is the advanced malfunctions, where they don't get any warning. So it'd be just like in their unit, they're sitting there and some problem happens. So they get to develop that thought process as well and get used to the stress involved. And we will go back through startup, we'll go back through the emergency procedures and trip applications as well during the advance. They just don't get a warning. And then after they've completed their simulator training, initial training, then they come back every year for 2 or 3 days, depending on the panel, for refresher training, and we'll go through startup, the emergency procedures, and advanced malfunctions. And any changes in the unit as well, we'll cover during that period of time. I did it that time. Okay, well, I'm learning what all the buttons do. I think I got to the next one. Let me just double check that. I did. Okay. Has anybody got a simulator I can practice on? There we go. A little to the right for the next presenters. So some other benefits of the our simulator, of course, training, the initial fresher training, prevention of freeze up, as I discussed. They at least get an idea what's going to happen. My experience, I went to tech school, kind of thought I knew what an operator was about, but after I started training on my first panel, then I really got an idea what an operator was, you know, what the expectations were and the experiences you might go through. And that's a real issue of the Center for Operator Performance. One of the engineers that does consulting there had mentioned that's been a real issue in some of the plants he's visited. And yeah, in team coordination, we have, sometimes we'll bring in up to 3 operators and go through a startup on the simulator. And so they learn their communication, dealing with changes in their unit, how it affects each other, and just working together. And we also have our control system technicians do some training on the simulators. They get to practice on there before we let them loose on the real unit. It gives them a little more confidence. And used it a lot to verify and improve procedures, especially on the units. Before we started them up, we flushed out quite a bit of issues with the simulator, just having the operators go through them. Controller validation and tuning, if we'll try to set up the controllers on the simulator and do some basic tuning there. It's usually pretty close to what we ended up on the unit. And same with safety logic validation. For some of the logic, we have Chorus actually model it for us, and even then the engineers will come up with some problems with the way it was designed. But we've also added on systems that will do the logic that's actually used in the unit, and we validated that logic before we've even implemented it in the unit. And so we save a little startup and commissioning time doing that. We have used it for network security testing. We actually set up the system on a simulator and tried to hack it. Abnormal situation management. I'll give them a leak scenario, so I'll bring in a gas detector, seal leak on a pump, and then have them go through how they would isolate that situation. And it can help them think through where the best points to isolate a unit are, and also minimize the amount that they need the outside operator out there during the event. We've updated our DCS system in several of our plants from up to a multi-level graphic system, which was completely different for the operators. We tested the graphics on the simulator first. We updated them there, made sure all the points worked, and then used them to train the operators before we started up the unit with the new graphics. Incident prevention, if we have a problem in the unit, it could be mechanical error, whichever it was, and it's a complex problem, rather than redo it again or possibly have it again, we'll train our panel operators during the refresher training on that particular incident and how to resolve it quicker. And we also test our control system software updates on the simulator. When we get an update, we do it first on the simulator. There we go. Okay, so this is just an example of some of the trip applications in our ethylene 2 unit. And most of them revolve around our large compressors, which can result in a plant outage. We do have trips for all of those, or trip applications. One of them is for a crack gas compressor trip with an immediate restart. So it'll park the unit in a position that will allow the panel operator to focus on that compressor and get it running again and feed forward without having to shut the plant down for a longer duration, which could be a day outage. And we do have panel backups, but this gets them in a state, it takes a lot of work away from them so they can focus on getting the unit back on. Our reactor off spec, that's acetylene to ethylene converter. If it's off spec, we have to flare the effluent for a while. It reduces feed on the finishing side, so the flare system can be managed cleaner and frees up the panel op to focus on getting that reactor back on spec again and addressing what caused the problem. Ethylene refrigeration compressor trip as well, stabilized the system so they can restart it. Recently developed a feed pull package, so if there was a furnace trip, that it would cut rates through the process based on a certain number. It would calculate how much to pull feed on all the controllers. And the furnace feed reduction application, so it'll pull about up to a third of the feed out of the furnaces in about 2 minutes, which really helps with the finishing upsets and reduces flaring fairly readily. And our developers have said that practicing these on the simulators were a key component of getting them to work properly by testing them several times and by having the operators trained so they're used to using them in the unit as well. And further on flare reductions, we've used them extensively over the last 20 years. Our first simulator we had on site was 1999, so we've been using them for about 24 years. So over that time, we've saved millions of dollars on flaring reductions during startups. And the other benefit there, sometimes we've changed the startup quite a bit, and it was perhaps a little bit intimidating for the ops, so they got used to the idea and practiced it before they got to use it and had to use it in the unit. And shutdowns, we've reduced flaring by half. I had panel operators in on the simulator that never done a controlled shutdown on the unit, and we worked through some strategies on reducing flaring, and they were able to execute it in the unit and reduce the flaring by half. Propylene refrigeration startup, it's got a steam driver and a gas turbine as drivers to it, and there's several false load valves involved. It's a very difficult machine to start up. It's prone to surges and high temperatures. On that one, I trained a panel operator that hadn't done this before on the simulator. He went out and started that machine up without a surge or high temperatures. So we've been quite happy with the results from it. And we tried a different strategy on the acetylene reactor off spec rather than just flaring it. We worked out a strategy of reducing rates and a certain percentage of off spec that we could keep it running through the plant and use the ethylene bullets while recycling, so pretty much minimize flaring on some of those upsets. And that was too many. So polyethylene 2, this is from my co-author Roger Young. He's the training specialist there. They take 12 days to qualify, but they have more products to run. Same as the other examples, procedure development, graphics reworked. Now, one impressive one is they did an application for a startup that requires 100 steps in an hour. So this used to take 2 panel operators. They've got it down to 1. They had to run this on the simulator quite a few times and work out all the bugs. But they did manage to, they regularly use it now successfully. They also have a shutdown, 30 steps in 10 minutes, a different trip recovery application as well, so it kind of parks it in a certain position so they only have to work on reaction and distillation to get feed back into it. And a hot transition application that helps them change catalyst platforms while maintaining production and limits the amount of off-spec product. This is past research with the ASM consortium, and it's just an example of ways that we have used it to test our systems on the simulator to validate that these changes are going to be helpful and will be successful. So the first one was about our multi-level graphics system, and then some around alarming, and an interface design project as well. And more recently, with the Center for Operator Performance research, we tested a shadow box training technique. This was Gary Klein's working on the development of that, and we tested that on the simulator, and we use that for new operator training as well on the simulators. And in a troubleshooting course as well. It's a classroom course. We've actually do scenarios on the simulator and use screen captures in the classroom course. A mental model study. That was actually quite an interesting project. We put our panel operators through some scenarios, and Gary Klein and Joseph Borders were sitting behind them, watching them respond to them and working through how they work through problems. They also published a paper on that one. Alarm automation impact, which Beth is here to talk about next. So we'll get into that in more detail about that project. That's about smart alarming and our use of our trip applications. And a train the trainer guide, a cargo, which we tested on the simulator as well, and we're rolling out in the site. And all that research was on our course, Dynamic Simulation. So in conclusion, our simulator program has exceeded our expectations. It helps develop tacit knowledge and decision making. The use of high fidelity models was a good fit for us. We have complex processes. We've gained a lot of value from that. And this is my job security line. Full-time simulator trainer is very important on this. Just to keep the system update, we've had example on our site, actually, we didn't have one, and the simulator was collecting dust after a while, so now we have full-time trainers. Leadership support is critical, not only financially, but to free up the operators so they can have time to train. As I mentioned, simulators are used by several groups for testing of their systems as well, and you do need support by several disciplines, the control system people, application engineers. In our project management, when we make a change in the unit, one of their checkboxes is to update the simulator, and that project pays for it, so we don't have to go back and ask for money for the simulator. And of course, continuous support from Chorus in updating the models when we make plant changes, software updates on the different systems, they help us with that. And some resources, I went through that pretty quick, so if you're looking for more detail on it, you can get my book from Amazon, Troubleshooting Tactics, How Process Operators Make Critical Decisions. And I'm always curious on these topics, so I added my email address. And we have Graham from Chorus right here too. I don't know if his booth's gonna be open much longer, but you could probably ask some questions, or you'll be on the panel too, so.